I'm waiting so we pop up on LinkedIn because sometimes it cuts it off.
Okay.
Good morning and good afternoon. Welcome to another episode of Coffee and Compressed Air with Dr. Elvira Rakova and myself. I'm actually going to let Dr. Rakova introduce this one because you've spent so much time on this topic.
Yes. Hi, everyone. Please grab your cup. I have tea. It's already 4 p.m. here. Don't forget. I realized that all our past coffees were a little bit more in a rush with all the presentations and were more like a workshop. I also brought slides today. And I just said that I'm leaving compressed air. And of course, we're using this just for clickbaits and that people start watching us. It's a poor marketing. I don't think that I ever leave the compressed air, but I just want to tell you the story is that now we started to be more active on the YouTube. So please also subscribe to our YouTube channel. You can find all our episodes there, a lot of interesting things, great guests and interviews. So don't forget to subscribe to Direktin Technologies YouTube. And I went to YouTube to analyze what is happening about compressed air, who is talking about it, what hashtags we need to use so we also can be fine. And the first thing, I think I typed like compressed air, industrial something. And the first video was compressed air is the most horrible technology in the world. You need to replace everything by pneumatic drives. It's dirty. It's that. And then, of course, it was a video of the company who sells some electric solutions. So very understandable. And then I hit a deja vu thing because in 2012 I started my PhD at University in Dresden, and my project was comparison of pneumatic and electric drives. So I had to develop the methodology to choose when to use electric drives, when to use pneumatic drives. So of course, I spent 6 years on that, but we're going to pack it in the 15 minutes. So this is how the world works now, right? TikTok, pack a 6-minute video into 60 seconds, pack your 6 years of research and testing into 15 minutes. So this is what is the episode about. And the problem is when I had to develop this comparison methodology. So I set up a test rig and so on. I started to check where and how it is used. Then I discovered a whole new world about the compressed air system. So first of all, you cannot replace it. If we just started from the beginning, you cannot replace it. So it is used in so many applications, and it's not just an old technology that you would think about. It is very robust technology. It is used for so many safety circuits in nuclear power plants, in any mining, in any remote locations, in the constructions, in the aerospace. As a safety, when you have, for example, shortcut of the electricity, you always will have a safety system that runs on the pneumatic logic. And it can be used into the soft robotics. It is used in the petrochemical solutions. It is used a lot in the food and beverage, where we have a very strong agents for cleaning, where the electrics just cannot handle it. So this is why it's like it's probably not been more involved because it's such a robust technology. It has to be so simple with so few moving parts that it is easy to clean, and you don't have any electronic part that will be damaged. So it is a whole world that I think we will do more and more videos about how it is used. I mean, I'm not going to say now that it's used in the computers. In the past, you could run a computer on this in the mnemonics. This is what I studied when I was at university. So And it is yes. I also was born in the USSR, so it's a little bit of artifacts here. And in some, I know, 19th century, it was a city clock in Paris, also run on compressed air. There are
Mhm.
also some crazy applications, of course, but it is, you cannot replace it. So you cannot just say replace compressed air by electrics, because electronics and electric drives, they will not be able to handle it. But an interesting point, and where we're coming for the coffee of this day, what if there is an application that I can replace?
Mhm.
Should I replace everywhere? And then you could say, oh wow, it is very expensive and it is like doesn't make sense. But in some time it makes sense to replace. And let's talk now, just to tell you, I'm talking now about the pneumatic cylinders. So today we'll speak only about pneumatic actuators. So it's not about the blowing application, it will be a different topic. So I talk only about, we really need to go out of the box and think we have a task in a machine and we need to move a part from A to B. So we need to push something, and what could be used here, pneumatic cylinder or electric cylinder. And let's say it is the same conditions where electric cylinder can be used, the linear actuator. So should we go for pneumatic or electric? I have a few slides. So let's pack my experience into 10 minutes. And then we'll do a great TikTok out of that. And now, basically, things that are extremely important are, so I'm just going to leave the screen like that. So first of all, when you compare, you check the application requirements, what I just mentioned about. Another thing, when I started to compare electric to pneumatics, I actually realized that 99.9% of pneumatic actuators are oversized. And we need to first size correctly pneumatic actuator, because we cannot compare apples to pears, because it's completely different things, right? So we need to size it correctly, and it doesn't make sense to use oversized comparison to do the oversized, check the oversized actuators. So this is an extremely important point, and in the future I'll go more deeply into that. But basically, the main reason of the energy consumption of pneumatic and electric actuators is that electric actuators, they consume what they have to perform, and if you change the force of the task, it will the speed and also the momentum will be adjusted to that. In pneumatic actuators, you cannot change it, so you get what you get. And this is why you cannot just get a perfectly sized electric actuator with adaptive control and compare it with any cylinder size. And you saw probably other videos of ours where I talk that cylinder sizing also doesn't make so much sense. So this is the first moment. It's extremely important. So whenever you see any YouTube clickbaits, any white papers that electric already consumes less, it's not always the case. So it depends on how it is sized. It depends what are the pressure levels of pneumatic actuators. And I'll go into this in the next workshops, in the next coffee and compressed air. And it's not only me who did this work. You can check, for example, Festa also has a I think it was Dr. Gauchel who did a lot of papers on also comparison of well-sized actuators on the consumption and electric drives. So also not an easy topic, but anyway. And then what is actually basically the key decision? It is to compare the total cost of ownership. And here I have very easy diagram. So the selection of the technology. First, check the specific environment, pneumatic or electrics. If it's not, check the speed variations and multi-positioning. So what does it mean? That electric drives, they have a perfect velocity curve, right? So here you can see the perfect velocity curve. Pneumatic, because of the compressibility, it's not as perfect. So If you need some very specific positioning and velocity controls, or need some sophisticated stuff, just uh, use electric drives. Just for information, is not an advertisement of Festo, so it's just the actuators that were used for this particular test rig. And uh, after that, you designing again the machine, so you realize that I don't need any specific. It's just a simple stamping. I need to bring from A to B the mass. It's a package moving something else, so we don't need a special positioning. It's not a precise application, not a precise application. Think about if you need a compressed air supply. Do you want to have a compressed air supply? Is this only you have only one operation that where you can install pneumatic drives, or you can have an electric? You want to have a completely electrified machine, what is also possible. I mean, if you have a lot of actuators, the price of this will just skyrocket. But well, your choice. And once you compared all these steps, and you now really think, okay, now I have to decide what is going to be fair, electric or pneumatic drive, need to compare the total cost of ownership. And when we go into the total cost of ownership, it's basically not just the what we usually see for the pneumatic. It's always low investment, high energy cost. Electrics, it's high energy costs, low investment. Sorry, high investment, low energy cost, right? So it's always like, okay, this or this or this. How should I compare? And basically, when we go into the total cost of ownership analysis, so first we need to go into the sizing, we need to go into the energy consumption analysis, the economical analysis, the payback period, and only after that we can understand which drive to use. Or of course, you can get a catalog from suppliers and follow their marketing. No, of course, I'm joking. So let's go. I'm going to pass a little bit ahead because I have really a lot of information that I realized. But let me go to that slide and we have a separate workshop about this. So this is the final total cost of ownership for the, attention, well-sized pneumatic drive. So it means not oversized for this size, perfectly sized pneumatic drive and electric drive. So what we have here in the total cost of ownership, it's energy, investment, maintenance, and you also can get some room cost. So it is calculated as the part of the part of the installation. So, and here you see, even though it is well-sized actuator, the consumption, of course, is going to be way higher than for the electric drive. So the investment will be also smaller than for the electric drive. And then there are also various optimizations and energy reduction ways to reduce the consumption for the pneumatic drive. And you can reduce the pressure. You can reduce so this is the standard one. So this is, you can reduce the pressure. You can well-size the actuator, leave the pressure and leave the same, reduce the bore of the actuator, reduce the pressure return when the stroke goes back. You can also use the recovery, or you can use also the bridge circuits. About this, we also have a completely separate discussions, but I just want to show you that there are way more steps than just open the catalog and look at the investment cost of the pneumatic actuators. And here I want to show you an example of this is the pneumatic TCO cost of the cylinder that is usually chosen, based on the calculators that exist online, based on the best practices. For example, okay, I have 1000 Newton, I get this bore. And this is the electric actuator. But this is the pneumatic actuator improved. So what here means that the cycle cost, so how much it costs per cycle, including the investment, energy, maintenance, room cost, and everything, pneumatics is better. So it is cheaper. And of course, you can here see the amortization also time. Here was a calculated period of the 5 years. So it starts to amortize itself in 6.5. But this is basically how it how the impact of the well-designed system has, that it can be almost the same from the total cost of ownership perspective, but if you size it correctly, the pneumatic actuator can win. And here the cherry on the cake, the result of my long research. You can also get the dissertation on Amazon and read it. But this is basically different actuators tasks. So for moving the different masses with the different velocity, it shows here the horizontal and vertical drives. And here it basically shows where pneumatic won and where electric won. In terms that where the cycle was cheaper, the total cost of ownership per cycle of pneumatic drive was cheaper than to install the electric drive. And in this case, the electric drive was more expensive. And this is basically the entire idea of this, that it's not, it has to be really thought through, that it's not that electric, now it is electrification, let's go for electric drives. It doesn't mean that. Electrification, if we look, for example, in the agenda of a Green Deal, it means removing the use of natural gas. So using the renewables energy to electrify the processes. So it means that it doesn't mean that we have to get instead of using the utility, how we used compressed air, instead of compressed air, we need to use totally electric drives. So this is the first thing. So I think we need always to think about how we message that. So because I work a little bit also on the policy making and on this kind of like level in UNES and UNIDO and UNES. So it's always talking about the electrification. And sometimes for our industry, it can be very confusing, but it's not electrification that you need to electrify the processes. Compressed air is a utility. It's like we have a water and we cannot replace water for a lot of stuff. We might, but I'm not a subject matter expert there, but still. The same thing for compressed air. First of all, check first the application. Check not only the investment cost, but also the energy cost. But before even you go there, be sure that you sized correctly your actuator, your application. And then if you define that actually electric drive is better, then go for it. And it has to be really, even though like I work in pneumatics and this is my field, I still vote for fair choice of the technology from the total cost of ownership, from the LCA perspective, life cycle assessment perspective, the most efficient and let's say the cheapest one, and what is then better also for the environment, because we need to get the entire picture. And it's not only just about the cost. I think it's for the machine builders, especially for the engineers, it's bringing high value also to your customer, right? So you are designing something with that you thought through about. So, or suppliers of cylinders, that you provide the systematic thinking to systematic approach to customer rather than just like one cylinder. So because I see a lot of suppliers now developed, of course, electric solutions, totally understandable. Of course, it has to be developed, there has to be like enlarged the portfolio, but the guidance for the user, where should I use what, because it's still hard to sell the electric solutions because they're simply more expensive. And if you're a producer of the production line, you cannot make your machine more expensive, you will be thrown out of the market. And the pneumatic drives, they're cheaper, right? So, but the person who will pay then the energy bill, it will be then the end user, the end customer that will use it. So this is why, as usual, our compressed air, you think that you find answers to all the questions. We pose more questions. So I don't know how it is useful will be, but just don't focus only one single solution. So there is no single answer. There is no any single situation in life where you have a definite answer. But at
Mhm.
least how we can support and help you, it's the methodological approach. What is your input data? What is your output data? And which drive has to be used there? You also can use EasyCast software. Simply just download it, and we have cylinder calculations there, so you can see all the consumptions of the systems and then calculate very quick TCO of that. But yeah, and don't watch videos where it says the compressed air is bad and then have to replace by everything. It's extremely only for teeny tiny single applications. Yes.
Mhm. Yeah, and I think that's most things, and like you said, clickbait, like there's so much information being thrown at people that I've been in so many marketing, tutorials, marketing courses, and all of them say, make the headline, don't do this ever. And then you'll get people to watch. And I'm like, okay, but I personally get frustrated when I'm scrolling, trying to get ideas, and they're like, clickbait. And then you open it and you're like, okay, the value wasn't even there. Like you didn't actually follow through with that. So I'm
Yes.
hoping clickbait is somewhat going away and people are at least questioning things a little more. But I think it's
Still
coming
follow
to
all the
it.
clickbaits. I still click clickbaits.
I know.
I
I
think
just,
I
yes.
mean, we will do the white paper on these 5 things you need to know before you purchase electric drive. So yes, I agree,
Yes.
but it's
Yes.
a lot of overwhelming information, and
Mhm.
I think it would be really nice to get also feedback from our listeners on like what
Mhm.
topics you would like to know, what experts also maybe we can invite to
Mhm.
talk about the things. But like electric and pneumatic drives, it's a question like to be or not to be in compressed air systems. It's been there forever, and I still can't believe that it's still here. So and it's even more and more getting attention of people, because a lot of end users were telling me we want to have a completely electrified facility. Yes, but then calculate the consumption. The consumption of electric drive is also higher. The efficiency is not going to be, it's not actually 80%. You need to, there are
Mhm.
so many things, like it has to be, need energy like for braking, for the return. There are so many things like to start it, to stop it, the controls of the, also from the CO2 perspective, it's not sometimes better. You need to have really LCA analysis. So it's not about electrifying is not using the not renewable resources. It's using
Mhm.
renewable resources. Sorry. So it's not about electrifying the processes. And sometimes energy managers get into this while reading the white papers from the Green
Mhm.
Deals and European Commission, all these things. There is a lot of confusion about it, a lot of confusion. So by replacing, so even if you have so much like passion and heart towards sustainability and make the world a better place, as I do, as you do, it's it's not the way to play. It's not that like by electrifying it will solve the world. So we need to have the full LCA analysis and also
Mhm.
energy consumption analysis. So I'll be posting more these comparisons. Have a lot of research done on them, measurement of different cycles and actually showing. And not
Mhm.
only me, there are also other companies that do that, researchers
Mhm.
that also do that. So it's very interesting. But really, once you size correctly pneumatic drive, then like it's like game over. it's it wins. I saw sometimes in some cases it even consumes the same as electric drive.
Wow.
So it's and but usually it's like people consider it as a factor 10. So like that the electric drive consumes 10 time, like pneumatics consumes 10 times more than electric drives usually. But if you size it wrong, and
Yes.
it's extremely hard in our field to size it correctly, because it's always the same pressure levels that people prescribe and not so much to do with the diameters of cylinders. And this is why of
Okay.
course, in some cases, it can consume also way less. So it's from case to case. It's
Mhm.
extremely individual thing. So to go more methodological about that, it can be extremely important.
Incredible. Yeah, I think you gave people a lot of things to think about. Hopefully, some engineers get a hold of this and kind of dig a little deeper there because it can make a big difference.
Yes. Yeah.
And they're being sold on both ends that, this is better, this is better. Everybody has the best. I keep saying this, everybody has the best, most efficient thing that they're selling. Like their tool is the most efficient, which in certain cases it most likely is. But a lot of it's the same. At the end of the day, it's just how you use it and size it appropriately, make sure it's in the right spot, and everything else in the compressor system has to be lined as well for it
Exactly.
to work. So,
Exactly, exactly. Look at the systemic approach. Look at the suppliers that bring you systemic approach to help you not only to buy a cylinder, but to adjust the valve and explain you how to regulate the velocities of that, get the consumption and understand these things. It's extremely important. We're not living in the world anymore where we sell just and buy just one component. We buy the solution, the
mhm,
service, the solution, and this is something really is changing.
mhm.
We are overwhelmed with the information of the
Yes,
catalogs,
yes,
videos, compressed air every week. So
yes, absolutely. All right, I think we will wrap it up for today. You guys know where to find us. If you have any questions, make sure you're following Dr. Elvira's page, as well as our Direktin page on LinkedIn. We'll be sharing a lot more there. And there are a lot more in-depth videos on our YouTube channel. I
as
will
well
put
as
them.
as well as your page too, because if you want to get some inspiration and get really interesting posts, please follow Danny. It's amazing.
Thank you.
Influencer in compressed air.
Thank you. Working on it. So I'll put our YouTube channel in the comments so that way you can go there and go through the library. Dr. Abir has so many, many good videos on there already. And we continue to add more as we go and have more conversations. So thank you, and we'll see you guys next week.
Bye and enjoy your evening or your day.